Hi, my name is Jose. I work in developer relations at Google.
And I am Adarsh Fernando. I am a product manager on Android developer tools.
So the goal of this talk is not to make you test more. We have been doing that for years. That's done. Now we want you to test better. We test to verify our code and to catch regressions, but I think first and foremost, we test to improve our own productivity. So we can take on more tasks and be more productive, which is the goal, or you can also go home early, whatever. We're going to talk about testing strategies, so that means, of course, the boring testing pyramid. I have a problem with this pyramid. Integration tests are in the middle. Why are they in the middle if end-to-end tests are more integrated or have more integration than integration tests?
Is it getting hotter? Is that what the line
Yes.
is? Okay, hotter.
Actually, I have two problems with the pyramid. What is an end-to-end test anyway? Are those the tests that make network calls? Is a UI test where I start an activity already an end-to-end test? Actually, I have three problems with this pyramid. It's not a pyramid, it's a triangle. Anyway, let's start looking at what a scalable testing strategy could look like. Scalable here means that all the decisions are done so that tests are reliable and run quickly, so you're not blocked when scaling your app. So I'd like to propose to you a new testing pyramid. This is the testing pyramid recommended for Google Apps internally. And as you can see, it has 5 layers and a lot more opinions than the other one. This doesn't mean that every Google app follows it strictly, but it's a good baseline for scalable strategies, as we will see. We broke the tests in 5 categories, and before diving into their attributes, let's talk about their general properties. So the size of the test obviously increases as you go up the pyramid. Not necessarily the scope. We'll talk about that in a minute. Also, fidelity, which means how close the execution environment is to what your users will see. And integration level, of course. Consequently, speed and reliability increase as you go down the pyramid. Given that our goal is to maximize productivity, speed and reliability are going to be pretty important. So why don't we just create unit tests? Well, we have to be pragmatic, and there's no way, or it's very hard to fully test an app just using unit tests without testing the integration between its components. So each layer tests different things. Also, we should note that not all apps are going to form a pyramid if we count the number of tests per category. For example, a media player might have a lot more application tests and not that many components, so it will have fewer component tests. So, as a side note, let's talk about scope and size, because they're not the same thing. And we'll focus on this example, which is a calculator app that shows error message when you divide by 0. The app has this function somewhere in the code that checks if the denominator is 0, and then returns the appropriate division result, which is an error in this case. And we definitely want to test this, because you could be returning the wrong error, or you could have a problem with the if statement. We could create a UI test that clicks on the buttons to generate the error, so 1 divided by 0 equals, and then take a screenshot of the screen. And yeah, the screenshot test would definitely cover our statement, which is what we wanted to test. But it's also going to start an emulator or whatever runs Android, an activity, render a UI, interact with it 4 times, take a screenshot, and compare every single pixel. If we use this approach for, say, the 100 different errors across operations, we would need 100 different screenshots, and that could take, I don't know, minutes to run, maybe. So the size of the test is massive compared to what we want to test, which is the scope. So going back to our pyramid, the screenshot test would be pretty big and placed around maybe application tests, given its size. Whereas if instead we create a very simple JVM test or JVM unit test, it would take milliseconds to run. A unit test would have a very small size, so it would match the scope of what we want to test much better. Even if we create the 100 unit test for every error, they will still be fast, simple to understand, and easy to maintain. So I think that example is pretty clear, nothing groundbreaking here. But what about the screenshot test that we saw before? We still need to verify the UI. We need to make sure that the UI renders the error message correctly, and a JVM test is not going to be enough for that. Also, we need to use different themes, font factors, font sizes, locales, etc. So, the scope of the feature that we want to test, which now is the UI, is bigger than in the previous case, which was just an if statement. But this test, I think, is still too big. Do we need to inject user actions? Do we need the whole UI? Actually, the only thing that we need is the calculator screen, so that we can verify the font, the color, the position of the error, etc. And because compose is declarative, if you follow the best practices, you'll be able to create a composable and pass the exact state needed to generate exactly this UI without injecting any user actions or dependencies. So by doing this, our test is a lot smaller, and now it can be considered maybe a component test, but this doesn't mean that we're done testing the feature. It will probably require more component tests and bigger integration tests as well, but because we have covered a lot of the cases in the lower layers, we can limit the number of big tests, which is what we wanted, an actual pyramid. Now, let's define the categories formally. It's not the most exciting section, so brace yourselves. From the bottom, unit tests, nothing new here. They have minimal dependencies. They execute on the host machine, so that's your workstation or CI server. They don't access the network. They target debuggable builds. The ownership is the media team. We'll talk about this. And they're executed before a merge. So I think we all agree on everything. So let's move on to the more novel categories, component tests. They are slightly bigger. They might test the integration of multiple classes, and they can run on emulators or Roboelectric. The rest is really the same as unit tests. Of course, if you create your own testing strategy, which is what this talk is about, by the way, you can add more attributes to the categories. For example, whether they can be screenshots or screenshot tests or not. So how are they different from feature tests? Feature tests include external components, external to the feature in their scope, and they add real devices as possible targets as well. You can test the integration with a mocked network, and the ownership is shared with other teams. Obviously, your test strategy might not care about ownership, but it's very useful when you have a big team to define who owns what. All right, let's move on to application tests. They are big tests where you throw everything in, network calls, authentication, third-party services, navigation, state restoration. They only run on Android, so no JVM, and they can hit backend servers. Fast tests can be run pre-merged, and slower tests can be run in a nightly run or after merge. And finally, release candidate tests are very important because they're the only ones that use a release build. So that's a minified or an optimized binary. It's very easy, as you probably know, to release a bug to production with a problem with minification because of bad program rules or something like that. So you can run these tests maybe daily or whenever you have a release candidate ready. And we're done. That wasn't too bad. You can find this pyramid with a lot more detail in the new testing strategies section of the documentation, where you'll find a lot more descriptions of each category. The goal, by the way, is not for you to follow this particular strategy or this pyramid, but to make it yours. So the recommendation is that you write down a strategy document and share it with your team, and keep updating it. It's not about having strict guidance, but having a conversation. The goal is to share a common language when talking about tests, and split the ownership so that no tests are left unmaintained. Now that you have all those tests, you need to invest a little bit in infrastructure so that they run. You can run them locally, but they're going to be run on continuous integration most of the time. So to give you an idea of what big apps are doing, and this is not coming from an exhaustive survey or anything like that. It's just anecdotal data. But I'd say that a build and test time of 25 minutes is kind of typical. It's a good target to have. Top-heavy apps might be closer to 50, but that's already a lot. But of course, it can be better. 10 minutes is a dream, and it can be achieved doing a lot of caching and throwing money at the problem, getting beefy servers and aggressive sharding. And of course, you need proper configuration. So check out the talk that Orimas gave yesterday and follow his advice. It pays off to invest in your build. Android X has 800 modules, and the average build time is 22 minutes. So it's pretty impressive. More than 50 minutes or an hour is way too much, and the productivity is lost, especially if you work across time zones. You probably know about this. Then you'll have serious problems. Part of your strategy should also define where and when each category of tests are run. You can be opinionated, setting a specific list of devices per category, and this can depend on your most popular devices or the ones that you optimize for. Cool. But we're not done. A testing strategy is also affected by the tools, frameworks, and techniques that you use. So let's start with screenshot testing. Most of you probably already know what a screenshot test is. It's a test that takes a screenshot and then compares it with a previously approved image. We're not going to get into much detail here, but screenshot tests can be used in almost every category, maybe except unit tests in this particular pyramid. You can create component screenshot tests that verify that your UI components are displayed correctly in different situations, like themes, or bigger tests, feature, application, or even release candidate tests that cover bigger parts of your UI. The difference, as always, is in the scope. As with any other type of test, you should try to make them as small as possible to verify the subject and the test, that is, matching the size of the test with the scope and trying not to make them unnecessarily big. The problem with screenshot tests is that they are dangerously easy to create new ones. So our first recommendation is to think about limiting the number of screenshot tests as part of your testing strategy. There are multiple reasons for it. The first one is related to how and where you store the reference images, which are nothing but PNG files. You can check them into your Git repo, but you should take into account that Git is not optimized for binary files or large files, and this can make your repo grow in size very quickly. As alternatives, you have Git LFS, and you can also use cloud-based services to store the screenshots. They all have pros and cons. Our recommendation is that you start checking the screenshots into your Git repo, and if it becomes a problem, then you do something about it. It might require rewriting history, but that's another issue. So this second issue is something that you can't ignore, actually. When you take a screenshot, the screenshot tools use libraries that use other libraries that use other libraries that end up making platform calls to render things like text, shadows, etc. So if we take a screenshot and zoom in and then compare platforms, you'll find that Linux, Windows, and Mac all render these things differently, even though they should be equal, but they have subtle differences that are going to create false negatives. You have multiple ways to overcome this. The simplest solution is to set a different threshold. All screenshot testing tools have a way to set some tolerance when comparing images. Another option, which is getting more popular, is to always take screenshots on the same platform. Given that all your tests are eventually going to be run on CI, you can make your CI system generate, compare, and commit the screenshots for you. There's a lot we could say about screenshot testing, so if you want more detail, you can check last year's talk, which was called Easy Screenshot Testing, or check out the official documentation that we just released. Now Adarsh will give you an update on the previous screenshot testing tool.
Cool, thanks, Jose. I'll give you a small break. Okay. So with all the solutions that are available in the community, and there's a lot of really good ones out there, you might be wondering, why are we adding a new one? Well, we wanted to create a tool that was very easy to set up within our existing tools, one that was highly integrated to AGP, Android Studio, etc. One that focused on Compose, so being forward-looking, and could be run very fast from your host. Now, if you are developing with Compose in Android Studio, you're likely already familiar with Compose previews. Compose previews allow you to render your Compose layouts right in the IDE without having to deploy to a real device. So it really allows you to kind of see how your app looks across many different devices and configurations really easily. So we're leveraging that same technology and the previews that you may already have as part of your project, to run screenshot tests for Compose right from host. So you can test all the different layouts and different themes, large screens, phone sizes, different orientations, and then easily turn those into screenshot tests. Screenshot testing with Compose previews has been out for a little while, and we've gotten a lot of really good feedback. And we've been trying to really address that feedback. So it's been taking a little more longer time than we would have liked to get to stable, and we're still at Alpha 7 currently. But we want to actually share some of that feedback and kind of where we're taking the product next. So we heard that it's super easy to set up your existing previews and convert them into screenshot tests. For example, all you have to do is copy your preview over to the new screenshot test source set, and they're screenshot tests. Just that easy. All you have to do is run a few tasks from your command line. So one task to generate the reference images for your previews using a good stable build, and another one to actually run your test after recent changes to your app to see how that impacted your layouts. But we also heard that when you have very large projects with many modules, performance can decline quite significantly. So, for example, we have a 200 module app that we kind of do some performance testing on. And so for that app, we were seeing that discovering all the previews in the project, rendering them, and doing the validation, that would take over a minute. And we knew we could do a lot better. And so after significant optimizations across the whole process, we're able to improve that speed 10x. So what previously took more than a minute, now just runs in a few seconds. So it allows you really to test your app from the smallest components to the more complex layouts. On the topic of complex layouts, as Jose mentioned, you may want a more relaxed threshold, because if you're triggering app failures or test failures on just a couple of pixels being different, you're going to get very flaky tests, especially when you look at some of those text rendering issues that are inconsistent across platforms. So now you can set a threshold for your tests using the image difference threshold property in your Gradle build script. Here I'm applying a 1% margin of error for my screenshot tests, giving me a little more wiggle room when testing more complex layouts where minor changes don't trigger a test failure. These performance and functional improvements are already available in Alpha 7 of the plugin, so please try it out today. And like I said, we're definitely hearing the feedback and trying to address them. On the topic of feedback, there are some things we heard that are not yet available, but we wanted to give a sneak preview because there are some significant changes. So as I mentioned, we heard that developers really liked how it's easy to create previews, screenshot tests by just simply moving your previews to that separate screenshot test source set. Separates your tests from your production code, something we should all be doing. So much so that developers wanted to actually have a similar kind of ability to organize previews that they use day to day for iteration. So not even the ones that they use for screenshot tests, the previews you use today. So we're actually creating a new preview. We're actually renaming the screenshot test source set to just preview. So you can you have one place to kind of store the previews you use for day-to-day iterative development as well as for screenshot tests. So you can have them all in one place. And the best part is you still can view those previews alongside your source code. So if you're making iterative changes, it's not like you have to go flip between different locations. We will have mechanisms in place to allow you to see those previews, even if they're in a separate source set right by the source code. Okay, and I'll pass it back to Jose. You're back on.
And then you'll improve your code coverage by doing that. So it's, very nice. All right, so let's talk about Row Electric, because it's something that you should consider for your general testing strategy if you don't use it yet. Roboelectric, if you don't know, is an open source framework maintained by Google. It lets you run tests in a simulated Android environment inside a JVM without the overhead of emulators or devices. Many big projects use Roboelectric to increase speed and reliability of the tests. For example, it's used extensively at Google. But it's not a complete replacement for emulators. It doesn't support all APIs and features, and it doesn't even have a screen, for example. However, by running tests on JVM, you reduce the expenses associated with running on real devices and emulators, which can be considerable when you have to test on multiple devices. So it's a lot faster and more reliable. And I completely made up that chart, by the way. It doesn't mean anything. Roboelectric started as a collection of mocks called shadows to allow developers to create unit tests. In my opinion, this was because everyone put their code in activities back then, but now we have, best practices and dependency injection and flows and everything, and you don't really need to do this anymore. It's kind of a smell. But I'd like to focus on the other way to use Roboelectric, which can also reduce the size of your tests while keeping the scope. You can actually run Compose or Espresso tests directly on Roboelectric, on JVM, which makes them a lot faster and more reliable. Again, you will be limited by Roboelectric support. For example, web views are not supported. And if you take screenshots, you'll see small differences compared to emulators, similar to what we showed before across platforms. However, if you follow architecture guidance, you'll be able to isolate your UI from dependencies that would be problematic, like WebView. So in summary, it is a very reliable way to run behavior and screenshot UI tests. And because we don't talk about Roboelectric too much, I get asked a lot if this project is still maintained. And yeah, just check out the commit history. It's used a lot internally at Google, and it gets a lot of updates. If you want to read more about Roboelectric, we also added a brand new section to the documentation talking about Roboelectric testing strategies. So, speaking of UI tests, with all the tools that we've already talked about, we have enough to start thinking about how to test or how our testing strategy verifies different screen sizes and form factors. It is extremely important to automate this process because app developers don't usually have a phone, a foldable, a Chromebook, and a watch when developing features. So it's very common to implement a feature on a phone, but at the same time break something on a tablet. So regression testing is super important. The alternative is basically to put more resources on QA, but every form factor is going to increase costs and delay releases. So what should you test? Well, the first thing is the obvious one, the layouts. Screenshot tests are a very effective way to catch these regressions, but testing all of these combinations would be super costly using devices. So let's see what we can do about it. In Compose, you can always use this beautifully named composable called device configuration override. This emulates different window sizes, and it can be used anywhere. It can be in a device test or a local test in Roboelectric. In this example, we are rendering an expanded layout inside a portrait phone. Obviously, this is not going to replace release candidate tests, but it will catch most regressions. Next, if you use Roboelectric, you can set the width, height, and density of the screen using qualifiers. That's it. It's literally just one annotation. You can even do this in the middle of a test with set qualifiers. This is extremely powerful and keeps the tests small. However, we're talking about testing layouts. If you want to verify the state restoration or lifecycle calls, then Roboelectric might not recreate things exactly the same way a device would. So let's talk about state restoration, because that's something important to test as well. If you use Compose, we have state restoration tester, which is something that lets you emulate a state restoration in Compose very, very easily. But it won't, of course, let you verify the lifecycle calls in activities and things like that. You do that in bigger tests where you test compatibility with emulators, probably. For verifying state restoration, you have Espresso device. It lets you send commands to the emulators to rotate and fall, etc. And that way you can test that the screen state and the navigation state are restored correctly in different layouts when configuration changes happen. For more information and details and code examples, check out the test different screen and window sizes page. I would give you a URL, but you're going to Google it anyway. So, big tests can catch a lot of different issues, but they are more prone to occasional failures, especially if they run on emulators or devices. Emulators and tests on devices have actually come a long way. I think we're in a much better place now, but they're not going to be as reliable as JVM tests or Roboelectric tests. Even if a test fails only once every 1,000 executions, nowadays tests are run many, many times per day. So a flaky test will find its way to ruin your productivity. So there are 3 things you can do to prevent flakiness. The first one is to prevent the synchronization issues. That's kind of an obvious one. Configure devices correctly and implement retries. Sometimes the flakiness is like your fault. Your app is doing things in the background that your tests don't know about. And there are 2 strategies to fix those. Idling resources, let your app communicate to the test when it's busy or idle. It's like adding instrumentation points in your app. By the way, they're called Espresso idling resources, but this is just branding. They work in Compose and UI Automator or whatever. Some big projects are very successful just with idling resources, but I think it takes a while to get them to work correctly. So the new approach that we recommend is to wait for things to happen instead. So let's see how you do this using different frameworks. In Compose, we have these functions that you can access from the Compose test rule. Wait until at least one exists, does not exist, exactly one exists, and node count. Espresso doesn't have this functionality baked in, but you can find a lot of snippets, actions, and even wrappers over Espresso that do this. If you use UI Automator or any of the frameworks that use it, you can wait for things with a snippet similar to this, calling device wait. But we're actually trying to release an extension so that it's automatically applied to all the calls.
Cool. So if test flakiness is still exists and you haven't been able to fix them, you can always try retrying, since it's almost impossible to have a fully reliable test suite. You may need to use retries in multiple situations to prevent issues, such as when connection to the device is lost or test failure occurs. How you implement retries depends on the testing frameworks and infrastructure you're using, but typical mechanisms include a JUnit rule that retries any test a number of times, a retry step in your CI workflow, or a system to restart an emulator when it's unresponsive, which can be handled automatically with a solution called Gradle Managed Devices. So let's see how Gradle Managed Devices work. Okay, so as we kind of learned, while end-to-end tests are the smallest part of your testing pyramid, they are a crucial step towards ensuring that the important user flows for your app work really well on Android. And when you need to test your app against platform behaviors across a number of device types and configurations, Android virtual devices are a great solution. But there are some headaches associated with integrating AVDs into your CI in a reliable and scalable way. And that's why we introduced Gradle Managed Devices, which leverages the build system to fully manage the lifecycle of each device before, during, and after your tests. So you just describe the devices you want in the build script, and the Android Gradle plugin creates them, runs your tests on them, and shuts them down at the end of your tests. And we've added ways to kind of help you scale with GMDs as well, such as utilizing snapshots to quickly boot each device to a clean state, running tests in parallel, prompting test retries as needed, like we talked about, sharding your larger test suites across multiple devices, and using stripped-down versions of the system images called automated test devices that run headless with much fewer resources required to run each device. But we're also constantly improving the stability and performance of GMDs as well. And so this kind of flowchart kind of shows what I talked about. We have the initialization, running your tests, and the shutdown flow for GMDs. So example one advantage that I mentioned, GMDs uses emulator snapshots to reset the device to a clean state between tests very quickly. However, when generating those snapshots, we sometimes entered an error state that corrupted or invalidated the snapshot. And so the whole flow, the whole test would just fail. Not great. So in AGP 8.5 and higher, we've significantly reduced the likelihood of using an invalid snapshot by validating the snapshot during the initialization process and automatically regenerating a snapshot if required. So this optimization has resulted in a 75% decrease in those error rates when using Gradle managed devices. So if you haven't already tried it, please give it a shot. And like I mentioned, we're always listening for feedback. So you knew we had to bring this icon at some point in the talk. So there's just one more thing. So that was Gradle managed devices, one more approach to bigger end-to-end tests that we'd like to talk about that targets the top of the pyramid and lets you create tests in a new way. Okay, the reason we do these talks is to help make it easier for developers to adopt an automated testing approach to app development. But we know it's not easy. You have to learn multiple testing frameworks and then implement and maintain those tests. That's why so many developers find it really difficult to make the jump from manual testing to automated testing. It takes a lot of time and effort to do so. Manual tests, by comparison, are easy to write, they're easy to understand, and they're easy to execute, but they're really hard to scale. So what if we can combine the ease of manual testing with the scalability of automated tests? That's what we want to accomplish with a new approach to testing called Journeys with Gemini. Journeys significantly reduces the barriers to automated testing by simply allowing you to define your end-to-end test using natural language and leveraging Gemini to interpret and execute those tests, making it easy for anyone to write tests by simply describing the goals of their test. Now, if you tuned into the session yesterday, you would have seen Tor's demo of an early version of Journeys with Gemini. I think my heartbeat was like 200 BPM while that was happening, where you defined a new type of test artifact called Journey and ran it right from Android Studio. And so journeys are scripts that include the goals of your test written in natural language that you commit to your project just like any other instrumented test. And like any other instrumented test, you can run those tests on any number of connected devices. When you run a journey test, Gemini interprets your prompts and converts them into actions it performs to satisfy the goals of the test. With journeys, tests can execute in a more adaptable way as well, since Gemini determines the best actions to take each time it runs your test. Assertions are also much easier to define and provide greater flexibility, allowing you to describe the successful state of your app during each step of your test. And Gemini determines the requirements of each assertion, whether the requirements are met by visually analyzing the app. In fact, the Google Maps team have already started to use journeys to write some of their tests. For example, this screen was previously very difficult to test using existing Android testing frameworks because that was the map view is a custom UI, and it didn't expose a lot of the layout hierarchy required by existing frameworks. But with Journeys, they are able to simply describe the app state, and Gemini analyzes the screen to determine whether the test should succeed or fail. For Google Maps, Journeys is a game changer that allows them to create tests they couldn't previously. And when Gemini is done testing your app, test results will provide rich artifacts such as screenshots, videos, and logs, so you get a detailed understanding of how Gemini executed those actions and potentially why an assertion might have failed. So we're very excited about Journeys with Gemini. Not only do we think it will lower the barrier of entry for automated testing, but really open up new ways of testing your app that weren't previously possible. Can't wait to bring it to you in a future Canary version of Android Studio, so please stay tuned. Okay, some things we talked about, like Journeys, are coming soon, but the rest you can find in the testing guidance, so including links to samples and code labs, and if you have feedback or questions, don't hesitate to talk to us in the Android booth. Thank you all so much.
Thank you.